Good morning. I'm Sujeesh Krishnan. I'm the CEO of Kinnami, here to tell you about our secure, resilient data mesh for the digital edge. So in the old paradigm, almost all data processing has happened centrally in some kind of data center. But now we're increasingly reliant on a world where data is being collected and processed at the edge on things like IoT, sensors, drones, satellites, etc. Gartner estimates that by 2025, more than half of all enterprise data will be generated and processed at the edge, up from just 10% in 2018. Now, there are companies out there like Microsoft that look to secure data securely in the cloud, but no one's doing that across a distributed network and a connected set of devices. That's what we uniquely do at Kinnami. So several different sectors are having challenges dealing with distributed data at the computing edge. These challenges range from the lack of physical security out at the edge to having to manage hundreds or even thousands of devices at the edge. Kinnami is already working in sectors such as space and critical infrastructure to solve this problem. The lack of proper data management at the edge creates some significant issues from a critical infrastructure perspective. The most interesting event that happened recently was the issue with the GM self-driving cars. They lost internet connectivity both in San Francisco and Austin that resulted in these cars not knowing where to go, creating a huge traffic jam in the middle of the city. In this case, a pretty benign situation, just a traffic jam, but you can imagine in other mission-critical kind of applications, the lack of resiliency could cause significant problems. We've seen other issues like the Colonial Pipeline cyber hack that caused localized fuel shortages that drove prices up pretty high in those regions. So Kinnami provides a distributed data management and security software platform that protects data, provides data availability, all in a holistic manner. So our software works in the following fashion. It takes any type of unstructured data. So think about a video, a picture, or even a document. What we do is we first break that file into multiple pieces. Each of these pieces is then individually encrypted. And then those encrypted pieces are now stored in many places across a distributed network. So the idea is that by breaking a large file up into pieces, it allows for better storage as well as network optimizations across the network. This software can run on very low size, weight, and power devices, as well as servers and other kinds of platforms. So on the other end, when data is put back together, data is being recompiled from the best available places for any given user at any given point in time, all of which is being orchestrated by a dynamic AI-based policy engine that makes decisions on where data is stored, where it's managed, etc. So let's take a real example. So we're doing some work with the US Air Force at the moment. So in search and rescue missions, when people need to go out to rescue folks, there's a lot of data that needs to be collected in these environments. This could include coordinates, images, videos, etc. Now in a communications degraded environment, this is virtually impossible. So you have rescue pilots flying around in the dark, trying to locate people, get line of sight, collect this data, and then move back to a place where there's some kind of communications to be able to push that data back to the rest of the rescue mission. As you can imagine, very inefficient, risky, and time-consuming. So with our software on board, for the first time, the US Air Force is now able to deploy a swarm of drones that can go out into the field ahead of any kind of rescue mission, securely collect information off that person to be rescued, so accurately identify that person, collect biometrics, etc., and then hop that data across that swarm of drones. So even in a comms denied type of an environment, hop the data across the swarm of drones up to a point where there's communications availability to be able to share that information across the rescue mission. As you can imagine, a much more efficient process. So over the past few years, Kinnami has taken its concept from R&D to a working prototype that's now being piloted across both the defense as well as the commercial sectors. So we see our competition according to two dimensions. The first is where data is stored, and the second is where data is how data is managed. So on the storage side, we have the big cloud vendors like AWS and Azure that securely store data in the cloud, but no one's doing that across a distributed network. So generally what we find is that when you talk about distributed data management, you need a completely different architecture, and that's what Kinnami provides. So just to wrap up, we are here looking to engage with you all that are working on edge-related projects to explore pilot opportunities. We're also interested in strategic partnerships with technology providers that may be interested in embedding our technology into your own platforms. So that's Kinnami. Thank you for your time. Feel free to stop by and see us at the booth. Thank you.